Hello, this is the class of data mining, and I'm going to continue about the data warehouse. I guess you already have the idea about the data warehouse. We learn about the OLAP, which is online analytical processing, and OLTP, which is the online transaction processing. We know that the transaction means the operational and the analytical means you want to use the data for your analysis. And we need to distinguish between the OLTP and OLAP. Okay. So we already learned about the basic concept of the data warehouse and OLAP, and we are going to learn more about the data cube and OLAP. And you already learned about the data warehouse, the concept of data cube. Okay, and we are also doing the lattice of cuboids understanding, and I'm going to continue what we are going to learn more about the conceptual modeling of the data warehouse. So in this case, we have the two things for modeling data warehouse. First is the dimensions, and the other is measures. Okay. There are three kind of modeling that we will learn here. Is the first is star schema, and the other is Snowflake schema, and the last one is fact constellation. In the star schema, it is a fact table in the middle connected to a set of dimension table. Okay, so we have dimension table means the attribute. And Snowflake schema is a refinement of star schema where some dimensional hierarchy is normalized into a set of smaller dimension tables. And it forms a shape similar to Snowflake. Okay. Snowflake maybe is a kind of snow. Okay. So yeah, you can see the diagram later. The other kind of data warehouse is fact constellation. We call this is fact constellation. It contains of multiple fact tables, shared dimension tables, and it is viewed as a collection of stars, therefore called galaxy schema. Okay, so yeah, this is only the terminology galaxy schema, or the people also use it as a fact constellation. In the star schema, I show you in this part. Okay? We have a lot of dimension tables. We have dimension table, we have dimension table, we have dimension table, and those dimension table are surrounding of the fact table. What is the fact table? The fact table is the data containing all the attribute, like what we saw before. We would like to know about the time key. We would like to know about the item key. Okay? We want to know about the brand's key. We want to know about the location key. Okay? We do not want to have all the data at the same table. We want to have only the sales fact table with the key. If we need the key in details, then we can access the table time. For example, if it is related with time key. If it is related with the item key, then we need to access the table item. So the item has the item key, we have the item name, brand, type, and supplier. If we want to know about the brands, then we will connect to the brands table. If we want to know about the location, then we will connect to the location table. If we want to know about the measures, like how many units sold, how many dollars sold, and what is the average sales, then because this is the measures. Okay. So what I mentioned before, we have dimension and measures. when we have the dimension, yeah, it is related with the table that you already stored in your database. But for the measure, yeah, it is only about the how you can define the numbers, maybe the price or the sales, and etc. The other kind of schema, we call it Snowflake. Okay. So what is the difference between the star schema and Snowflake? In the star schema, you have only until dimensional table, only dimensional table. Okay. You have the fact table in the middle, and then it is connected to another dimensional table. And what you want to see next is about the sub-dimensional table. This is sub-dimensional table. If we have the item key, item name, brand, okay, and then the type, and then the supplier key, yeah, it actually related to one particular item. But if we have another key, so we want to connect to the supplier key. So the supplier key, we have another table, which is the table supplier. It's also about the location, and it is a city key included in the location. Then we have another information about city. So the city is the city name, and then the province it is located at, and the country. Then what is the difference between Snowflake and star? Yeah, you can see that in the Snowflake, it contains more table like the sub-dimensional table. So this is the Snowflake schema. What about the fact constellation? So the fact constellation means you have several facts. You have more than one fact. The first, we have sales fact table, and yeah, the other kind of fact table is shipping. After you have the sales, of course, you want to know whether the product or the item has been delivered. If it is not delivered, then you can claim something. Then it should have the sales fact table when the customer bought the item, and then shipping fact table means when the product has been delivered to the customer. Some of the key are the same, like the time, item, but now we have shipper instead of brands. Okay? And then we have the location, and the location have more items, like from location to location. Okay? The measures are still the same. Yeah, whether you want to include some delivery costs, okay? And also include how many items that you already ship, because maybe we bought 10 items, but now you cannot get all the product. You will get only one at the first time, and then you will get the remaining product at maybe next week. So we have fact table, and then we have dimensional table, and those dimensional table are surrounding the fact table. So we call this is the fact constellation. So because we have more than one fact, and we need to constellate between those data. In the concept of hierarchy, I guess you already learned when we learn about the data preprocessing. The concept of hierarchy, we can just use the top bottom, okay, or if you have the bottom up, there's also a kind of hierarchy. If you can see in the top is the generalized one, and then if you go down, maybe you will get the continent. If you go to the next level, you will get the country. If you go to the next level, you will get the city. And if you get the details, you will get the name of a person who are in that city. Yeah. So the data cube measures. It is important when we have this kind of data warehouse. You need to understand the data cube, and in this data cube, okay, there are at least 3 categories for the measures. Okay, so the measure is this one. Okay, so this is the measures. How we can define the measures? So there are 3 kind of measures. The first is distributive. Okay. The other is algebraic, and last one is holistic. Okay, what does it mean? Distributive means the result derived by applying the function to n aggregate values. So if the result derived by applying the function to n aggregate value is the same as that derived by applying the function on all data without partitioning. So you just want to count. So how many data? And let's say sum or minimum or maximum. Okay. Let's see this one. In the R1, and we have the column 1. Okay. So I want to know the minimum. Okay, the minimum of this row is 1. And I have count. Okay, I have 3 data. And what about the average? So of course, you just get this value 1 plus 2 plus 3 and then divide it by 3. And what is the median? Median is 2, the middle value. Okay, so we can say that these are the measures. Okay, if it is related with the distributive, it is just a simple measure like minimum and count. If you are dealing with the algebraic, if it can be computed by an algebraic function with m argument, so m is the bounded integer, each of which is obtained by applying a distributive aggregate function. So let's say AVG and standard deviation. So you can see here we have the average of row. So we have 2, and then the average of row, this one we have 2, okay, 4 plus 6 divided by 2, okay, because the count is only 2. And A is not included because it's not available. There is no value. So we don't calculate based on this one. The last one is the holistic. The holistic means if there is no constant bound on the stated size needed to describe a sub-aggregate. For example, here I use median. Median is there is no such information to do this one, but we can get this median in order to describe the sub-aggregate. Okay, we have also the column-based information, the minimum, the count, and average, and the median. So these 3 concepts are the general concept of the data cube measures. Yeah, this is an old software about the data warehouse and data hierarchies, but I guess it is still relevant with our domain. It is the data mining. If you have the schema hierarchy, means yeah, you want to start from the small is office, and then go to city, country, region, and finally we reach to all countries, or maybe yeah, all regions, not only countries. And yeah, you can see here if you have the region, country, branch name, okay, and representative name, and then yeah, you have the dimension. The dimension is in its region. Okay, yeah, you can have those information like this one. The most important thing in the data cube is the multi-dimensional data. So sales volume as a function of product, month, and region. Product, month, and region. So those are the dimension, okay? Product, location, and time. And we have the hierarchical summarization path. Let's say if it is the product, then we have the product, and the upper level is the category, and the upper level is the industry. If it is office, the upper level is city, and then the upper level is country, and the other level is region. If with this time, the low level, maybe we have hour, yeah, we have second, yeah. But let's say if I have day, yeah, you can go up until year. And yeah, you can say this is the data cube, okay, because it is a cube, and we have the, let's say this is product, and then in the particular time, and then in the particular region. So let's say this is an example of data cube. You can see the different color between the brown, the gray, and the blue, and the green and white. We have the date, the first quarter, second, third, and fourth, and we have the product. Okay, so the product means the here TV, PC, and PCR. Okay, this is very old items. Okay, it is not a newest item, but I think still relevant. Okay? PCR maybe at the old ages we have the VCR video recording. Okay, but now we don't have that kind of video. We use just Netflix, right? Anyway, we have the total annual sales of TV in USA, and yeah, this is the USA and Canada and Mexico. So yeah, you can have like say I want to see only this part. So it means in the USA, and then in the fourth quarter, okay, and I want to see about the product PC. Okay. So the cuboids corresponding to the cube. Okay. If we have the three products like this one, sorry, three attributes: product, and then country and date, then we can define these cuboids. The first is product, date, and country. And then if we have 2D cuboid, means we want to combine two attributes: product and date, or product and country, and then date country. And the last one is the 3D based cuboids. So we combine all those three attributes. Okay. In the OLAP operation, we already learned the basic drill down and roll up. Okay. So I would like to give more details about this OLAP operation. So first is the roll up, or we can say this is the summarization of the data. And we climb up hierarchy or by dimensional reduction. If it is roll up means, yeah, you already know the some examples. I have the January, February, March, and April, May, June. Okay, so if I categorize into three different month, then I would like to use January, February, March, and we go to the next the upper level, which is quarter one. Okay, let's say this is Q1. So in the first 3 months, okay, sorry, quarter one is means January, February, March, April. Okay, so we have quarter. Yes. No. Okay, I'm sorry, I missed this one. So January, February, March is quarter one, and quarter two is April, May, June, okay, and so on. And we have the drill down. Okay, the drill down means, yeah, if you go to the higher level like this one from January, February, March to Q1, so the drill down is the opposite. So we want to see the details, or from the higher level summary or to lower level summary or more detailed data. In slice and dice, it is actually a project and select. If you have the slice, so some data has been sliced, and You can also dice. So dice means you can cut, or you can just project the data and select the proper one. In the pivot table, okay, we have the orientation. Okay, we can orient the cube, and then we can visualize, and we can limit from the 3D to the series of 2D planes. Other operation like drill across. Okay, drill across, it involves more than one fact table, and drill through, it means through the bottom level of the cube to each back-end relational table. So if it is drill through, means you want to connect with your database. If you are just doing the drill cross, it means you want to have more than one fact table cycle. So it is similar with the fact constellation. So this is the example, drill up and drill down. Okay, as I mentioned several times in the other section. So the France and Italy. Okay, so this is drill up. France and Italy, it is the country name, and this is the city name. What about this time? Okay, this time is still the same. Okay. And what about this component? Okay, those are items are still the same. So we just want to drill up the location. And what about this example? We want to drill down time. So we have fall, summer, spring, winter. Instead of doing with this time, we want to set with month. So January, February, March, April, and so on. Slice and dice. Okay. I can just set the slice according to one particular information. Let's say I want to slice according to winter. Okay. So it means I will just cut all the data, and then I will just get back with this. Oh, sorry, winter. Okay, not fall. Okay, so only with the winter data we can just use this one. About the dice is location. So we combine everything, and we need to specify what is the element, what is the data at the attribute. Let's say the location equals to Venice or Florence, and the season is winter, and sorry, or spring. Yeah, the winter and spring are chosen for the customer, for example. And the items, we can use the components or clothing. So components means you can combine from one item with another item, so it begins to be a component. If you are dealing with pivot, means you have the data, and then you want to check. Yeah, basically the pivot is similar with how you group or you can trip up. Okay. Yeah, in this case, I have the location Chicago, New York, Toronto, Vancouver. Okay, when I do the pivoting, the mobile modem item phone security now is the row, and then the location is now in the column. Okay. So let's say if I have this product 1, product 2, so I took this one from another site. We have product 1 as 40 and product 2 as 52, and then we want to drill across. Okay. Yeah, this is example. If you have the client 1, client 2, okay, and so on. So for every product, yeah, you can design how the client did the payment. For example, that one. So we have drill across product and customers, because maybe the product is more relevant than the customer, okay? Or sometimes the customer is more relevant than the product. Okay? So yeah, it can be either ways. Or we can use the drill through the summary report. So it will show to the CEO directly, for example, if you make a summary report, okay? And then yeah, we need to break up the product line. Another concept about the data warehouse is the StarNet query model. So in the StarNet query model, we call this each cycle is a footprint. Okay? So here it is a footprint. Okay? So if we have this blue and then we go here and then we go here and then we go here, it means yeah, this is already a kind of query. Okay? So let's say what this the center is here, and then I check this one. Yeah, this is about the location. So the location, when it is higher and higher, it reaches region. What about the time? Okay, so the time, when you reach this one, maybe you have the second data, millisecond, second, minute. Okay. And then if you accumulate those into the 24 hours, so you will get like daily. And then if you go up again, it can be a quarter, and yeah, the last one is annual, so it is 1 year. You can see the other kind of methods: shipping method, customer methods, customer and product itself, and organization and promotion. So this we call it as the StarNet query model. Yeah, you can also browse the data cube with the visualization with the OLAP capabilities with interactive menu manipulation. Okay, so at least until now you understand about the data warehouse and how many dimensions are there in data warehouse. So we learn at least 3. Okay, so star schema, star flick schema, and fact constellation. How many measures are there in data warehouse? In the measures we have like 3: distributive, and then algebraic, and the last one is holonic. Okay. Can you mention the typical OLAP operations? Okay, I guess, yeah, let's see, give you this operation. Okay, so roll up, drill down, slice, dice, pivot, and yeah, maybe others. Okay. So here, moving on the next slide about the data warehouse design and usage, and I would like to share to you about some implementation of the data warehouse. So in the data warehouse design process, there are two approaches. Okay, the first is top down and the other is bottom up. So top down means everything starts with the design and planning. It starts with overall design and planning. If it is bottom up, then it starts with experience and product. If we took a look on the software engineering point of view, there are two kind of model. The first is more waterfall model, and the other is spiral model. In the waterfall, it is more structured and systematic at its step before proceeding to the next. But in the spiral, the rapid generation of increasingly next functional system, and it has a short turnaround time. So because you can just combine. Okay. The data warehouse design process, the typical data warehouse design process is like this one. The first, you need to choose the business process model. Okay, what kind of process? Let's say the orders, invoice. Okay. So if this process is organizational, then a data warehouse followed. If this process is departmental, so it's only one department who make this one, so then a data mart model followed. So the information system team, usually they will follow what this data warehouse things, depending on your organization and depending on your department. When you have the data, you need to choose also the grain. Okay, the grain, what is the meaning by grain? It is the atomic level of the data. If it is smaller, then you can say it is fine grain. If it is like more in the bigger scope, then is the conceptual hierarchy. Okay, if you are using the dimension, you can choose the dimension that will apply to this for each fact table record. So for example, time, item, and supplier, and choose the measure that will populate each fact table record. Okay. Yeah, this is the recommended approach. Okay, when we have the multi-tier data warehouse, we have the enterprise data warehouse. Okay? So when we have the enterprise data warehouse, you can also deal with this one from the defined high-level corporate model. After we have this high-level corporate model, we can update the enterprise data warehouse, or we can use another format. Okay, so we have the data mart, and once we more refine the model, then we can make the data mart, and we can do the distributed data marts for the data warehouse. In the usage perspective, the data warehouse can be distinguished into three different kind of application. The first is about the information processing. We already learned how to do the process for the information, like can we do the query? Shall we do with the basic statistical analysis? We can report using the cross tabs or the tables, charts, and graph. In the analytical processing, the multidimensional array analysis of the data warehouse data, yeah, it is necessary, and some other basic OLAP like slice dice, drilling, pivoting. Yeah, this is for the analytical processing. But the usage for data mining is more about the knowledge discovery from the hidden patterns. So we will learn more about the association rules, how we construct the analytical model, and how we perform the classification and prediction, and presenting the mining result using visualization tools. When we have the OLAP, so there's another terminology, OLAM. Oh, what is it? Okay. So in this case, the OLAP is only the analytical processing, but the OLAM is the online analytical mining. Why we need to online analytical mining? Because high quality of data in data warehouse. So data warehouse contains integrated, consistent, and clean data. OLAP, it is based on the exploratory data analysis. Okay? So the OLAP is only for the exploratory, it's not only for the exploratory data analysis, but the government or the company or the organization usually set this OLAP as this exploratory data analysis. And we can do more with the analytical mining, like online selection of data mining function. We can integrate and swap the multiple mining function, algorithm, and tasks. When we want to calculate how many data cube that we can use, this is important. Data cube can be viewed as a lattice of cuboids. The bottommost cuboid is the base of cuboid. So usually this is the three dimension, okay, and we call this is the base cuboid because it's the bottommost. The topmost, we call it apex. It contains only one cell. So how many cuboids in an n-dimensional cube with L levels? Okay, so we already learned if we have the cuboids, okay, we can calculate
this item, this item, this item. Okay, how many of them? You can calculate, but I have the simple formula for this one. If we have n equals to 3 or 3-dimensional cube, and if its dimension has one level, then we can just t equals to the li. What is li? Yeah, li is the level. Okay, so if it is in the first end, it is the level 0. If it is in the level 1, it is in the second end, and we have level 2, and then we have L3. Okay. And if you want to check, now I have the n equals to 3, so its dimension has one level. So the t is 8 when the n equals to 3. But if n equals to 10, yeah, its dimension has 4 level. So we can just embed this formula. Remember that this is a product. A product is a multiplication. So a data cube of 3 dimension has time, location, and item. The total number of the qubit is 2 multiplied by 2 multiplied by 2. Okay, that's why our 2 multiplied by 2 multiplied by 2, the result is 8. 8 represent the how many cuboids that will be available when you have the L levels. And suppose now the time has 3 levels, so month, quarter, and year. So the total number of cuboids is 4 multiplied by 2 multiplied by 2. The cuboids contain more months or quarter or year or known. Okay, it can happen. So the efficient data cube computation, it is based on the materialization of the data cube. When you try to materialize this every cuboid, then yeah, this is the way to efficient data cube computation. And selection of which power cuboids are to materialize, it is based on the sharing, the size, access frequency, and etc. We can also use the operator like the SQL in order to fit the data cube and the database. Okay? In the cube definition and the computation, actually there are many business organization, company who use the cube definition, and then they try to explore by themselves. Like the DMQL is the data manipulation query languages. Okay? And also when you have this DMQL, you can define the cells. Okay, and then you can do the query. Okay. So for example, you do the sum, so you can compute the cube cells. We can use SQL. Yeah. SQL is not that difficult if you understand the concept, like select item, city, year, and then you want to sum the amount, and then it is from the sales table, and then cube by. Okay. Cube by means we want to cube by on this particular selection. When you want to compute the group by, so you need to define like date, product, customer, and then product, date, customer, product, customer, and then date, product, customer. Yeah, no, this is how the operator of the compute cube. In order to make the efficiency on the processing of OLAP, determine which materialized cuboids should be selected for OLAP. Yeah, because if you want to use all those materialized cuboids, so this one, if you want to use first one, okay, so yeah, that's possible, yeah, because yeah, all those things are in the OLAP. Okay. Now let's see if I have the materialized cuboids, okay, and I want to do the query. The query will be this one: brand, province, or state, and the condition is 2020, and therefore materialized page. So materialized page in this data set means the year, item name, city, or year, brand, and country, or year, brand, province, or state. Okay. And the item name and province or state where year 2020. So yeah, you can use this kind of materialized points, and yeah, we can explore more with the cuboids. So which should be selected to process the query. So in the dimension hierarchy, we know that the city will be the smallest one. After that, province, state, and becomes country. And if we are dealing with the time, we have the month, quarter, and year. If we deal with the product, maybe item name, brand, and type. The OLAP server architectures, yeah, you can see later. Maybe I will just be quick for this chapter. So the relational OLAP rollup. So it uses the relational or extended relational DBMS to store and manage warehouse data and OL middleware. It includes the optimization of DBMS backend and implementation of the aggregation logic and additional tools and services. So the relational OLP, it has a greater scalability. On the other hand, multi-dimensional OLP is yeah, it's common, okay, multi-dimensional OLP. But the architecture contains a multi-dimensional storage engine with sparse, okay, sparse is scattered. It is fast indexing to pre-computed summarize data. And the last one for this cipher architecture, we can see the whole the hybrid OLAP. It uses Microsoft SQL Server. It's flexible, low level relational, and yeah, good high level scenario. Okay, so you have the data warehouse design process. Okay? You have top down or bottom up. Mention the three kinds of possible application from data warehouse. Application. Can you still remember this one? Okay, information processing, and then analytical processing, and the data mining itself. And how many cuboids in a four-dimensional cube with two level? Okay. So the formula here actually it shows you L is the level, okay, and we want to multiply or the level. Okay. If we have two levels, then we have this 2 plus 1. Let's say for every time to extract the data, yeah, we only have two levels, so 2 plus 1, and we will multiply until n. So it means we will multiply until 4 times. So 3 multiplied by 4 then is 12. But please remember, we have the square. Okay, if it is 4 levels, okay, so it means 4 plus 1 power of 10. Power of 10 means the n is 10. If it is only 2, maybe we can just shorten it to. So if the data is 4-dimensional cube with two levels, yeah, you can measure with this one. 4 dimension with 4 dimension, n equals to 10 with 2 level. So it means 2 plus 1 is 3, 3 power of 4. Okay, and then we can get 4 power of 4, so we have like 16, yeah, 64. So it is all related with data warehousing. Okay? So in this data warehousing, we learn about the multi-dimensional view or model of the data warehouse. The data cube contains of dimension and measures. And we learn about three, which is star schema, Snowflake schema, and fact constellation. And for the OLAP operations, they contain drilling, rolling, slicing, dicing, pivoting. The data warehouse itself, actually, it is a multi-tier architecture, and it includes some information processing, analytical processing, data mining, and OLAM, online analytical mining. And for the implementation, actually, it is efficient computation of data cubes, but we have an issue like whether it will be partial or full or no materialization. And also in the OLAP query processing, it will be tough if we don't know about how to make a good query. And also the server, okay, so the server, whether it is relational or multi-dimensional, okay, so it will also affect this kind of study. Okay, I guess that will be the end of this course, and I will continue to the next section on the next class. Thank you very much for listening this class, and see you have good health always.